Generator connection accessories. Pressurization system. Introduction. A positive pressure of dry air is maintained inside the isolated phase bus enclosure to ensure that there is no ingress of dust, moisture, and contaminated air from outside, which may affect the performance and life of components comprising conductor, insulators, bushings, and accessories. Isolated phase bus when in operation are subjected to varying loads, varying ambient temperature during daily cycles. Consequently, the temperature of the conductor and enclosure will vary. The air inside the isolated phase bus will expand and contract depending upon its temperature. This results in the breathing of the isolated phase bus. As it inhales, it can take dust and moist air. These can settle on the surface of the insulators and bushings, which could lead to surface deterioration and compromising the dielectric properties of the insulators and bushings. Over a period of time, while the effect on the porcelain insulators could be marginal, the effect on epoxy insulators could be very significant. Ingress of contaminated air with moisture can lead to corrosion. Corona discharge. Localized corona discharge can lead to ozone formation. Reacting with the contaminated air results in acid formation. This can lead to corrosion and erosion due to incessant bombardment. In the vicinity of epoxy insulators and bushings, it can lead to deposition of carbon on the surface. This may ultimately result in a flashover to ground. Leakage from joints of an enclosure and insulator support arrangement will take place in a pressurized isolated phase busbar. International standards quantifies it. The unintended benefit of the leakage is that it will purge the gaseous products formed due to corona discharge. The isolated phase bus can be pressurized to ensure that the air inside remains dry and prevent the ingress of moisture and dust due to variation in load and ambient temperature. The isolated phase bus is maintained at a pressure of approximately 100 to 150 mm or 4 to 6 inches of water column above the atmosphere. An isolated phase bus is normally designed to be pressurized with dry instrument quality air with a dew point of -40°C. It is introduced approximately in the midpoint along the length of the isolated phase bus. This is to ensure that the pressure drop from the inlet to either end is kept to a minimum. When seal-off bushings are installed at the interface of indoor and outdoor sections, the inlet to the IPB for the pressurized air may be located on either side of the wall. Large size units require a standalone system comprising the following subsystems. A motor-driven compressor to supply air at designated pressure and discharge. Air tightness test as per ANSI/IEEE C37.23, 2015, permits leakage of dry air through the imperfections in the fabrication and assembly of the isolated phase bus. This volume of permitted leakage of air, with a design margin, can be considered for sizing the compressor. A filter-cum-dryer of adequate capacity, coordinated with the airflow. A pressure-reducing system, necessary set of isolating and control valves. Airflow and pressure measurement, indication, and control. Control panel for power distribution and protection of compressor. Backup redundancies can be built into the system as desired and mutually agreed upon. A pressurized isolated phase bus will leak since the installed system comprises a large number of sections and interfacing components that are bolted. To compensate for the leakage, make-up air is continuously supplied by the pressurization equipment to maintain the desired pressure. Per ANSI/IEEE C37.23, 2015 quantifies leakage, expressed as a percentage of pressure drop over a specified time. Because of the leakage, there will be a pressure drop along the length of the isolated phase bus from the point of entry to the extremities at either end. When the requirement for the volume of air is not significant, as in the case of an isolated phase bus with small route length and of low capacity, the input air for the pressurization equipment can also be drawn from either an instrument air pipeline or a station air pipeline in the plant. While instrument air will supply dry air, station air needs to be routed through a dryer. This makes the system compact and inexpensive. Compressor with associated switchgear and storage tanks will not be required. Thank you. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.